Hello everyone, welcome to today's lesson on multiplying polynomials. Right, so last lesson we worked a lot with adding and subtracting, and this time we're going to learn about how to multiply them. Right, so the easiest way to visualize multiplication is to use algebra tiles. Right, so we can split this into two, right, the 3x and 2x. Remember the x tiles are the long skinny ones. Right, so we got two strips of the skinny x tiles here. Let's color them in because they are positive. And there's three strips up here. Okay, so that's 3x up here, and then 2x right here. And now let's find the areas of each, right? Remember, whenever we multiply two numbers, you just find the area of a square or rectangle. You notice here that if we multiply them, right, we just get a bigger square, like an actual square instead of two strips. Right? And that applies for all of them here. Right? The area of a square or rectangular shape is just length times the width. Right? In this case, the length is and the width are both x. So we end up getting 6 of the x squared tiles. Right? So that's the area model. That's why this actually works. Right? Because again, think of it this way, right? We got 3 of those x tiles here and then 2 of those x tiles here. Each of those x tiles have the length of x. So when you multiply them together, the two lengths of x together, right, we just have x times x. Right, x times x. Remember with our exponent laws, this is just x to the power 1 times x to the power 1, add the exponents up to get x squared. And you can see we got 6 of them. So alternatively, as you can see, we can also kind of combine like terms as well. Alright, so when you multiply, right, we have the coefficients multiplied together, and then the powers multiplied together. Right, so now here's the main difference between adding and multiplication. Right, when we are adding, we only look for the like terms. We only look for the ones with the exact same power and variable. But with multiplication, it actually doesn't really matter what the power is or what the variable is. It's all going to be clumped up together. So in this case, we got 2 times 3. Right? 2 times 3. And then we got x's multiplied together. Okay, so we're still combining like terms here. The coefficient of the 2 and the 3, and then x and x. 2 times 3 is 6. X times x, like we mentioned earlier, is 2. Right? Because you can think of it as x to the power 1 times x to the power 1. Whenever we have exponents multiplied to each other, we add them. How about our next one here with brackets? Alright, so now in this case, we have to multiply everything inside a bracket. So once again, let's put our long strips here on top. So we got negative 3x up here. On the side, we got 2x minus 1. So two positive strips. Okay, that's our 2x. And then a minus 1 strip, or minus 1 dot, because that's a minus 1 tile. Okay, let's take a look. Let's look at the area. We got a length of positive x and a length of negative x. Multiply together, right, we get negative x squared. So again, same squares. Okay, and now we got a length of negative x up here and a length of negative 1 down here. Negative 1 times negative x is positive x. So as illustrated using the tiles, it's negative 6x squared plus 3x. Right, and algebraically, right, we can see that all we did was to multiply whatever's outside the bracket to everything inside the bracket. So this 2x here gets multiplied by negative 3x. So let's write that down. Negative 3x times the 2x. Right? And then we keep the sign inside the bracket here. And then we got negative 1. Actually, let me write it backwards. It's probably less confusing that way. So we got 2x times negative 3x minus, right? Minus the 1 here. So it's minus 1 times negative 3x. Right? And then we multiply as usual. So, command-like terms, we got a 2 and a negative 3 here as coefficients. Here we got negative 1 and negative 3 as coefficients. And then x as just x. So, 2x times negative 3x. 2 times negative 3 is negative 6. X times x, x squared. Next, we got negative 1 times negative 3 here, which is plus 3. Right? Two negatives make a positive, and then x, it's by itself. Right, just like that. So notice how this is a combination now, right? We are combining multiplication and adding, subtracting. Okay, so now what happens if they have different variables? Right, with adding and subtracting, right, we just kind of leave it be, right? Because if it's different variables, they cannot really add to each other. But with multiplication, right, it doesn't really matter that much. Right, so first we got the coefficients, got 5 and a 4, and then we multiply it by the a and the b. So together, it's just 20ab. Right, so remember what I said last lesson about when there's no signs, that means it's multiplication. So in this case, this is just telling us it's 20 times a times b. It's the same thing as saying 20 times the a times the b. Right, but we don't have to write the multiplication signs. Right, so right here. Right, this is an example that we did last lesson with the radius. Right. We are grouping the like terms together. Right, we got the two coefficients here. Variable just left by itself. So it is just 7 times the 4 times c, just 28c. Right, just like that. Right, once again, I forgot to highlight it earlier. So here's coefficients, variable 1, variable 2. So right here, two coefficients of negative 2, negative 5, variable 1, variable 2. So we got negative 2 times negative 5, and then times the d times the e, which is 10 de. Right, how about here? 100 and just negative f. Right, so our first term here is 100, or the coefficient, or like the constant. That's a lot of names for just a number. Right, and next here, you can think of this negative f as just negative 1f, right? And in negative 1f, we can see that we got the coefficient negative 1, the variable of f. So we just have 100 times negative 1, negative 100, f by itself. Right, just like that. How about a bunch here? So we work step by step. Coefficients, the 20, the 2, the g's, and then the h's. All right, let's multiply them together. Got 20 times the 2 as our number. The g, so we got g to the power of 1 and g to the power of 7. And then h to the power of 2, h to the power of 3. We're just multiplying everything together. Right, so we got like terms here, like terms here, like terms here. Let's multiply them. 20 times 2, 40. G to the power of 1 times g to the power of 7. That's adding exponents. Right? 1 plus 7. H, 2 plus 3 is 5. Right? Adding the exponents. And that's our answer. Okay, how about 3 of them? Same thing, like terms. Coefficients, negative 2, 5, 3. I, and then j. combine them together. -2 times 5 times 3. Now let's write it with dots here. Okay, and we've got the i's, and then we got the j's. And so you can see we're just doing the same thing here. Right? We're just like adding and subtracting, we always want to group similar variables together. -2 times 5 times 3, -30. I to the power of 13 because we got 3 plus 10. J to the power of 4 because it's 1 plus 3. Oops. Voila. Right, there we go. So that's multiplication. And of course, here's a bit more practice. Right? So what we did earlier was the brackets. We call this the distributive property. Right? So again, whenever we have two terms inside a bracket added or subtracted with each other, and with multiplication in front, right? We have to multiply every single thing inside the bracket with our multiplication term. Right? I think of it as like little flying arrows. Right? Whatever we're multiplying with goes to every single term inside, the little flying arrows. Okay, so we got 3k times 2k squared. Actually, again, I'll write it backwards so it's a bit more clear. So we have 2k squared, right, times 3k. What the? 2k squared times 3k. Right, and then we got plus 4k times 3k. Right, and then we just do business as usual. The first term here, 2 times 3 is 6. K squared times k cubed. Plus sign here. 4 times 3 is 12. And then it was k squared, because k times k. Right, and now going back to our last lesson, why do we flip the signs when we multiply with negative? Or when we have a negative number? Or what am I talking about? Why do we flip the signs when we subtract with brackets? And here's the reason why. Think of this as -1, right? -1 times 7L3 plus 5. Okay? And the reason why we flip the signs is because whenever we have a negative sign in front of a bracket, we are literally just multiplying everything inside by -1. Hence why positive 7L cubed becomes -7L cubed, plus 5 becomes -5. Alright, so this is why, say for example, if we have like 7L cubed minus 7L cubed plus 5 like this, right? That's why we flip the signs. Right? It's because we're literally just multiplying this bracket by -1. Okay. Oh, sorry, I'm realizing my head was in the way for that one. But yeah, once again, right, if we have something like this, right, we can see we flip the signs here, all negative. The reason why I flip the signs is because we're literally multiplying everything inside by -1, right? That's why we flip the signs. Okay, next one, right? Does it not matter how many terms are in your bracket? We do our little flying arrows. It applies to everything. First one is 4m squared times 2m minus a 7m times 2m, and then plus a 10n times 2m. Okay, so coefficients, do it together. And then we multiply all of that together. All right, 4 times 2 is 8. M squared times m is m cubed. Right, and then we have -7 times 2 is 14, -14. M times m is m squared. 10 times 2 is 20. N times m is mn. Right? If we cannot combine them via the exponent laws, we just leave it like this. Oh boy, we love fractions. So do I. Right? Once again, flying arrows. We multiply everything inside. 6p times 1 over 3 plus 9 times 1 over 3. And then we got, watch this, plus 8p. Right? Because, right, this is 8p here, this is plus times negative 3 over 4 minus 12 times negative 3 over 4. Alright, let's do the fun stuff. We can reduce ahead for our first one here. 3 and a 6 both divisible by 3. First term becomes 2p. 3 and a 9 reduced to 3. Alright, 4 and the 8 reduced to 1 and 2. And remember, because we're multiplying by negative 4 over 3, or 3 over 4, we have 2p times negative 3, which is negative 6p. Right, and then negative 12 times negative 3 over 4. Right, both divisible by 4. So we are working with 3 times 3, which is 9. Or negative 3 times negative 3, which is 9. And look at that. We can keep going. Now, we're adding, right? We got 2p and minus 6p. And then the constants. And then minus 4p plus 12. There we go. Right, so this question here is definitely on extending level. Combination of multiplication and combining like terms. And subtracting. Bunch of fun stuff all together. Alright. Oh yay, more problems. Yippee. Okay. Area of this rectangular head. Very oddly steep shaped. So the area is length times width. So all we do is multiply them. We got 5y and then 4xy. So 5y times 4xy. Coefficients get multiplied together. 5 and then 4 is 20. X is just by itself. You notice here we got 2 y's multiplied together. So it's y squared. Area of a basket port, same idea. Multiply all the sides together. Remember to put in brackets, right? Remember, this right here is a clump. Right? So it remains a clump in bracket form. Little flying arrows. 5x times 4x minus 3 times 4x. 5 times the 4 in the first one is 20. X squared. Second one, negative 3 times 4 is minus 12, or negative 12. Was 1x. Ta-da! Next, the surface area. Right, so a surface area is the combined area of all sides of a shape. So in this case, we got a cube, which means that we know all of its side length are 3n. We need a cube has 6 sides or 6 faces. And we know that the area of one face, the area, let's say the front face, is just 3n times 3n. That's our area, right? 3n times 3n becomes 9n squared. Right? 3 and a 3, that's 9. N times n is n squared. Now you can also think of it as 3n squared. Right? And remember, with our exponent laws unit, right, the exponent applies to everything inside. So it's 9, or no, yeah. 3 squared is 9, n squared is just n squared, so 9n squared. So now the whole surface area now. We know the cube has 6 faces, and area of one face is 3, or 9n squared. So all 6 faces together is 6 times 9, which is 54 n squared. Just like that. Right, So with multiplication, we just need to remember that the coefficients multiply to each other, and all the variables can just mush together. If they are the same variable, then we apply the exponent laws. So in this case, same variables, we apply the exponent laws. If there are different variables, so in case like this, the I and the j are different, we just leave it separately like this. That's all. Good luck practicing.